So you are there in the last class? What's your name? Aditya. Very good. Good. What happened? One minute. Give me a minute. Something going wrong. It's not coming. Okay, so you look at the hashing. So what we have seen for our other indexing schemes, especially the B plus type of tree, right, which is a very popular structure. Rather, if you see that our this MS these database vendors, though they do have a hash support, but primarily follow this B plus T type of structures only, right? Nevertheless, so what it shows. So it's a what we see. It's a there is a set of buckets or what we say unit of storage. In our cases, maybe a disk block, right? So what we have seen that in a disk block we have number of records, right? So that once I access the block, the records corresponding whatever in the block will be accessed. So our overall structurization is in such a way that the type of records we want to access are confined in a block or consecutive in a block, then the access will be faster. That is the basic philosophy, right? Same in what you have maybe read in OS type of scenario. So here, whatever we are trying to look at is that how database, right? So three type of scenario. One primarily for searching or querying on the database, which is the primary job. Other than what we are having is the insert and delete operations. So if your database is such that there is a lot of insert and delete going on, then whole your this indexing structure may go for a spin. Same as if I have a book, and if there are a lot of very frequently the chapters of the book are getting updated, then you have to rebuild the index which is there, right? So in a hash function organization, we obtained a bucket of record directly from the search key value using a hash function. So each of this key k will give me a value which basically indicates to the bucket. So hash function h is a function from a set of all search key value k to a set of buckets of the address b. Okay. So hash function is used to locate records to access, insert as well as deletion or the update. Right? Records with different search key value may be mapped to the same bucket. Thus, entire bucket to be searched sequentially to locate it. So if I the worst case, all the different search key value may be mapped to the same bucket. So like here, there is an example where we have 8 buckets, and this, if you remember the type of that instructor table what we are looking at. So if there is some hash function which map these to all 8 buckets, then we have this type of distribution. So there are 2 issues here. One is that some of the buckets are underfilled, right? And some of the buckets are maybe overflow will be there, right? So if there is a overflow and if there is a static hashing, that means you have a fixed number of buckets, then you have to have a split of the things or the chain of buckets into the things, right? And if there is a underflow, there is a lot of deletion and there is a skew type of things, then you waste on the space. But nevertheless, making this static makes your life easier, like because I have a set of buckets and a function maps to the buckets. So if there is a overflow, then we can have this sort of a chaining. The overflow bucket of a given buckets are chained together in a linked list type of things, right? Like in this case, bucket 1 is going on this type of chaining. So these are sometimes called as closed hashing. A alternative open hashing which does not use overflow buckets is not useful for database applications, because there may be a lot of what we are expecting the database, and there may be a lot of overflow type of scenarios. So hashing can be used not only for file organization but also index structure creation also. Right? So I can create a, one is directly going to the record. So there is a, so we name it as hash index, organizes in the search key with their associated record pointers, like me pointing to the records in the maybe in the secondary drive or some other places into a hash file structure. So hash indices are always usually the secondary indices, right? Because the primary index is mostly built on the already in the like a B plus type of tree or type of things. Mostly the secondary indices are on the hash function. Like if I have a primary index of the say employee ID or the student ID, but secondary index on the department name or other things like it may be the course like type of program like BTech, MTech and other things. Those type of things are there, right? So if I have a typical example of hash index, so I have this is on the employee code. So this is my bucket, right? And that points to the records into the actual database, right? To the tuples, right? So if I want to search from a particular search key, I first use a hash function, goes to that particular bucket, and then takes the pointer to the means follow the pointer to the actual record. Right? So how your hash function is organized is based on that. What is your the how you are constructing the index? How many a bucket? What is the number of what is the total cardinality of the bucket, and so on and so forth. So what we see that the disadvantage of static hashing is that in static hashing the function h maps the search key value to a fixed set of buckets, right? B fixed set B of bucket addresses. So databases overflow or grow or shrink with time. Right? So in especially all these databases, they may expand or at times shrinks at time, right? If initial number of buckets is too small, file grows, performance will decrease it too much overflow. So if I have a too much overflow, so there will be too much sequential or too much overflow and building up of those linked buckets, right? If the space is allocated to a anticipated growth, the significant amount of the space will be wasted initially, right? If I think that my overall requirement will be so many buckets and type of things and do anticipated things and things will be there. And also if there are database shrink due to delete and other type of several other reasons, then what we see, there may be a problem of space being wasted. So one solution is periodic reorganization. So which usually done if you have a static thing. So periodically reorganize the index. So in doing so, what we end up in that like you need to interrupt different operations and things like that. So this sort of things are being followed in our ERP system also. Also, if you see that different type of like say faculty database, etc., or staff database, people are retiring and joining new, so that overall reorganization goes on, right? So one other solution is that whether I can allow dynamically expand the thing. Right? So what we see, expandable hashing. Right? So there are several way of this type of expandable hashing, and depending on different context. So in this context, we see one such. Right? So good for database that grows and sinks in size over time. Right? So if it is a very slow periodic thing, then this may not be very useful, right? Like if I am indexing on the students, it may be a good thing, right? Because a lot of influx and outgoing of the students are going on a yearly basis, on a even some of the things on the half yearly basis, right? Like PhD and other things which goes on into the half yearly. But if it is on the faculty, it may not be, or staff, it may not be a good choice, because the number of say faculty retiring or joining is very less, or overall staff, if you say, it is not even 10% of the whole thing. So your shrinking and growing may not be that that large. Not only that, we have as a not only government organization, all organization has a capacity planning, right? So how many maximum faculty can be there, how many maximum staff can be there, there is a what we say underlining formula for that. For that, I can do a pre-compute of the thing, right? So it may not be useful when the database is not very dynamic, but it is pretty useful in number of cases where the databases are pretty dynamic. To be modified dynamically. So this is expandable hashing. So one form of dynamic hashing, right? So there are different other form of dynamic hashing. So one form. So hash function generates a value over a large thing, like say around b bit or b equal to 34, 32. So that is a huge number, right? 2 to the power 32 is how much? Something 4 billion type of things, right? Or something in that order. So at any time, only a prefix of the hash function to be indexed into the table of the bucket is addressed. Right? So in other sense, I have a huge provisioning, but I am using a portion of it, right? So let the length of the prefix be I. So I is less than 0 less than 32. In other sense, initially say initially nothing is there is I 0, right? So if I have something is I equal to 2, then I have 2 to the power 2, 4 buckets. Then if I go on increasing, I can go on provisioning the more buckets into the things. Right? Or if I shrink down, I can increase the things. But overall, my provision is for like 32 bit in the case. So that means 2 to the power 32. So the length of the bucket is this. So address bucket address is 2 to the power I. So initially it is 0. That means I do not have any data. The value of I grows and shrink as the size of database grows and shrinks. So multiple entries in the bucket address table may point to the bucket. Thus actual number of buckets is something always less than 2 to the power I. What I mean to say that it is not like that all the entry of the search are having individual buckets. So multiple entry may go to the one bucket. So ideally maybe going to what means best case or maybe worst case they're going to the one bucket. So the total number of buckets is ideally less than the 2 to the power I. So the number of buckets also changes dynamically due to the this merging, splitting, and of the buckets. So it is one such scenario. So in this case, I have I prefix say 2. So we have 4 options and go on type of things, right? So like it is shown in one. Okay, come to that. Let us see. Like initially has prefix is 0. So we have one bucket. So it is 1. We can have to the power 1, 2 buckets, and then I can have has prefix as multiple indexes, and I can have multiple buckets to the to address to it, right? So, so what we find that I do not have a predefined static bucket allocation, whereas I can have a dynamic bucket allocation of the things where here we are going on inserting. If you remember the original instructor table, and then I go on expanding the buckets. So if there is a again still a overflow, I can have a link with the I can create a say overflow bucket or the link bucket. Okay. So after insertion Kim record of the previous hash structure, so we have a so what we see that so I can have overflow. There is no deletion example has not been given. So what we can see that we can have if we there is no delete. Okay. If we delete, I can basically shrink on this bucket overall number of buckets into the things. So what we see maintaining a hash index, I can have this variable number of buckets. So if it is a large database, specifically if I have large number of secondary indexes, right, other than the primary indexes. So what we see that I can have this sort of a structure to manage it appropriately. So ideally, again for the database, as we are mentioning, my bucket is basically is basically mapping to a block in your database structure, right, or database storage. So that means in that bucket, these data sets are stored can be because usually my access of to the database is in a block fashion. So those blocks can be accessed in a single IO operations or database IO related operations, right? So this way I can have a overall better management of the for insertion, deletion, and of course searching of the data. Right. So if you look at the index file definition in the SQL, so there is a create index. You might have used. I don't know whether you have used in the lab. So you can create a index, so that will make your things faster. Right. So create index on particular relation having some attribute list. Right. So create index on say B index on branch type on say branch of branch name. So you created a branch index. You can create on the branch name. You can have on the branch code. Branch code is the primary index. So you can have different secondary index. So to drop a index, I can drop the index. So what happens usually in a normal database, you go on creating different layers, rather different views of the database, and then you can have different type of index for the accessing the things, right? Like if for an instant of a time you want to do some calculation or say some data mining type of operation, then you have some instances of the database and create those index based on your analytics need, and then you drop those indexes, right? Otherwise, that will be created in the database. So, so one benefits definitely has performance does not degrade with the growth of the files. Right? So we have this expandable. So minimal space overhead on the you have less number of so-called overflow buckets. The disadvantage is that extra level of indirection to find the desired record. So you have another hash index which has an extra level of redirection. So bucket address table may itself become pretty large, right? Sometimes larger than the memory space. So in that case, you may have to store in a secondary storage that itself. If you store that, then again those goes to the blocks. Again, you may require another type of hashing to access that. So it's a serious challenge of doing that. Cannot allocate very large contiguous area on the disk either. Solution B plus T structure to allocate. So now to find out that what is the hash index, now you have a B plus T structure. To locate the desired record in the bucket address table, changing size of the bucket address table is an expensive option, right? So if I want to this size of the bucket address tables, then you have to actually as if you are changing the whole philosophy itself, right? So how much things will be. So linear searching is an alternative mechanism, like you go to the thing and allows incremental growth of its directory equivalent to bucket address table at the cost of more bucket overflow. So I go there and then go on a linear searching on the database. So it all depends that how frequent your things are there, right? How frequently you may be looking at the want to look at the or search for the database, how inserts and deletions are there. Like if it is a say dynamic scenario like stock market and things, so it's a different. Even banking scenario where a lot of transactions are going on, there may be that frequency may be high. But if you look at our normal scenario, like we usually have during the beginning of the semester, there is a lot of activity on the database inserts and deletion of the things, like a lot of course allocation. But over a large number of time, another 3-4 months, there is no as such major activity on the things, right? Like somebody doing late registration, etc. there, but that is hardly, may not be 5% of the, or maybe a couple of percentage of the this. So if it is a very dynamic scenario, then you need to look into some other fashion. However, if it is not so dynamic scenario, then linear hashing, all those things may be a good options, right? So if you try to see that ordered indexing, what we have seen that B plus tree or other type of indexing and hashing. So cost of periodic reorganization is a challenge, right? If it is an index. So relative frequency of insertion and deletions is a metric, right? How much inserts and delete is there. So usually in a database we don't expect that a huge number of inserts and deletion is there, especially if the database is of the in the tune of data warehouse or type of things where that huge deletion or insertion is not there. Right? So is it desirable to optimize average access time at the expense of worst case access time? Right. So whether I want to optimize that, right? Whether it is it is always required, right? If a banking transaction or some exigency situation may be true, but if it is something say accessing say some student's record or updating something, it may not be always. I don't want to reduce the whole thing, right? Expected type of query, hashing is generally better at retrieving records having a specified value of key, right? So then hashing. If the range queries are common, ordered indices are to be preferred. So if I have a range queries, like within a range my queries are there, then this ordered index may be a good choice. But in practice, if you see PostgreSQL, one of the very popular open source SQL server, supports hash indices, but discourages use due to its growth performance. So they supports, but not so popular. Oracle supports static hash organization, but not hash indices. So it is not that dynamic hashing. Right? They also fall back to the mostly to the B plus T type of structure. So SQL Server supports or SQL Server or MS that Microsoft SQL Server, they supports only the B plus T. So over and above, still it makes a sense to the things. But they are all looking at mostly the relational database type of scenario. But if the scenario is of the data warehouse type of things, where this multimodal data is there and huge volume of data is there, which is usually time like what we say that those are not deleted, right? It is perpetual and stored things. That time this hashing, all those things may make sense. But most of those cases, we may not do some, not require some real-time operations. So it mostly we are doing some back-end analytics operations type of things. Okay. So this is, there are few things, but we will keep this one up to this part only, indexing and hashing, for the purpose of this particular course. Okay, so let me see what is happening. Let me answer the thing. Okay. Okay, if you have any queries, both offline and online. Okay, your all exams will be offline, right? Or in person? Okay, let me stop this.